In this lesson, we're now getting into our trig ratios and using that to calculate side lengths. Now, before we do that, we'll go ahead and review our trig ratios here. Again, the focus is ratios. So again, it's all about like similar figures with these ratios here. So like, for example, sine is always going to be, if I want sine of a value, and sine is going to be, and we're focusing on the reference angle. So we're going to always be given an angle, and that's going to be our reference. So sine is the opposite side from to the reference angle over the hypotenuse. That is our ratio here. And again, hypotenuse is still that opposite side from the 90 degree. So like, for example, if I want to know what is sine of J, J is the reference angle, right? So here's J. Well, what side is opposite from J? 60. And then what is the hypotenuse of this right triangle? 61, right? Because remember, keep in mind, the hypotenuse is always the longest side and opposite from the 90. So the hypotenuse is 61 and opposite is 60 from our reference angle. Then cosine is the adjacent over the hypotenuse. That is our ratio, adjacent to hypotenuse. So again, if I want to know cosine of J, so J again is our reference, but now adjacent to the reference angle is right next to it. So what's connected? 11. So it's 11 over, what is the hypotenuse? Again, 61. So again, notice our ratios here. So going back to that idea of the proportion similarity. So then last is tangent, which is the opposite over adjacent. So now here, notice how, if I want to know tangent of K, so K is our reference angle. So what is opposite to the reference angle? 11. Notice how clear opposite. So 11 over, what is adjacent connected? 60. So again, going back to the good old acronym, if you need to remember, SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent to hypotenuse, and tangent is opposite to adjacent. So SOHCAHTOA. So again, here, if we need that reminder, so with our SOHCAHTOA, going back to identifying just the ratios right now. So sine of B, so our reference angle is B. Sine is opposite to hypotenuse. So what is opposite from B? 24 here. 24 over, what is our hypotenuse? 25. Notice, clear opposite from our 90. So 24 to 25. So now here we want, whoops, sorry about that. I was trying to erase. Now we want cosine of B. So notice how cosine is, oops, sorry, there we go. Cosine of B, so again, our reference, and cosine is adjacent to hypotenuse. So now what is adjacent? What's next to it, side by side? 7. So 7 to, what is the hypotenuse? 25. And tangent. So tangent is always opposite over adjacent. Now we're using A now as our reference angle. So A is the reference. So what is opposite? 7. So 7 to, what is adjacent? 24 here. So go ahead and pause the video now and try the U-try. But notice, you are missing the hypotenuse. So what do you have to do first? Given you have a right triangle, you've got two sides. What do you have to do to find the third? Pythagorean theorem. So make sure to do Pythagorean theorem to get the hypotenuse, and then you can get the trig ratios here. And here we go. So you should have gotten, just to make sure, so 10 squared plus 15 squared is equal to c squared. You get 100 plus, so 225 here is equal to, excuse me, 225 here, so sorry about that, is 325. So here you get radical 325 But then from the c squared here, we're going to go ahead and round that to approximately 18. Or to keep it exact, we'll go ahead for now and leave it at radical 325. Now, for those who wanted to practice the simplifying, if you left it at radical 325, that's fine. Or you do have a perfect square factor of 25. 25 and 13. 325 divided by 25 is 13. Then what's the radical 25? 5. So if I wanted to be even more exact and simplified, then that is 5 radical 13. So now here we go. Cosine of A. So cosine is adjacent. So you should have said adjacent, which is 10 to 5 radical 13. However, you can't leave this in the radical form, right? So this was tricky. This is 10 to 5 radical 13, right? But you can't leave the radical. So this is radical 13 over radical 13, which gives you 10 radical 13 over. Remember, right? That's just going to cancel out to give you 5 times 13, which is 65. Then simplify here by 5, because here, this common factor of 5, and you end up with 2 radical 13 over 13. So that is cosine. Now, tangent of B, so tangent of B here is just good old opposite, which is 10 over adjacent, which is 15. Now you can simplify that by 5 again, so 2 to 3. Then sine of A, so again here, sine of A is our reference angle, opposite, which is 15 over the hypotenuse, which is again 5 radical 13. But again, you cannot leave that, right? So it's the same idea. You had to rationalize. So now you had 15 over 5 radical 13. So times radical 13, right, over radical 13. You end up with 15 radical 13 over 5 times 13 again, which is 65. Now, notice here, you can simplify both by 5 again, and you get 3 radical 13 over 13. So now here is when we would use our trig ratios, because we're looking for a side length, right? So we're looking for a side length ST. We have our right triangle. We've got 42 degrees. However, we only have one side and our angle here. So this is where the trig ratios come in. This is what we're solving for. So now we need to identify, okay, well, here's my reference angle. I know here that 9.5 is my hypotenuse. So I'm given the hypotenuse. And what is x in reference to the 42? Is that the opposite or adjacent? It's connected, so this is adjacent. So going back to SOHCAHTOA, which of the trig ratios are we going to use? Cosine, because we have the adjacent and hypotenuse here. So this is cosine of, not angle T. What is the measure of angle T? 42 degrees. That is equal to our ratio, adjacent, which is x, to 9.5. So now notice here, to solve for x, well, it's being divided by 9.5. So now we need to multiply, right, by 9.5. Sorry, running out of space here. So we multiply by 9.5. So x is approximately the length. So again, you're going to put in the calculator, cosine of 42 degrees times 9.5, and you get approximately 7.06. So that is the length. So that's how we use our trig ratio. So let's do the next. We're going to find QR, which is here. Now, all we're given again, so notice our side opposite. So here's our hypotenuse, and we're given this is our reference angle, 63 degrees. So where is X here? It is the opposite. So which trig ratio now are we going to use? Sine. So this is sine of P, which is 63 degrees. That is equal to opposite, which is X, to 12.9. So again, we're dividing X by 12.9. So multiply, right, by 12.9. So here you end up with putting this in the calculator. So if you need to, pause the video so you practice putting in, and you get approximately 11.49 as the length. So go ahead and pause the video now and try the U-try on your own. Here we go. So XZ, this is what we're looking for. Now notice, we don't have the hypotenuse. So that means we're going to use tangent because we're not given the hypotenuse. So tangent of our reference angle here, 58 degrees. So again, opposite, which is X, to 18. Then here, multiply because you're dividing by 18. So this is now X is approximately, you should have gotten from your calculator, 28.8. Now, these examples, we're still going to use SOHCAHTOA, but a little different. So now notice here, we're looking for DF. So here's DF. So notice how here's our reference angle. Also, I notice here our side opposite from the 90 is the hypotenuse. So this is what we're looking for. So what does the 17 represent from our reference angle? It is the opposite. So opposite hypotenuse, we're going to use sine of our reference angle, right? 51 degrees. Now that is equal to the opposite, which is 17, to our hypotenuse, which is x. So here's the key, right? Now we've got here, we need x in the numerator. So here, because we need the reciprocal, right? We need this to be x over 17, which means we're also going to take the reciprocal here. Keep in mind, this is like saying over 1. So the reciprocal is 1 over sine of 51 degrees. Now we're going to solve. So this is 17. Now we multiply, right? So multiply. Now notice what happens. This cancels out, yes, but what do we now have here? 17 times 1. Well, that's just 17. 17 now divided by sine of 51 degrees. So now notice, if it's the opposite, right, we end up having to divide. So this gives us approximately, practice putting that in the calculator, 21.87. So here, BC is what we're looking for, right? Now I notice clear opposite is the hypotenuse, but is there anything here? No, which means we're going to use tangent. What's our reference angle? 15 degrees. So here we go. What is opposite from our 15? 10.2. What is adjacent? Our x. So notice again, right? This is like flipping. This is x over 10.2, which is equal to reciprocal 1 over tangent of 15 degrees. So now when you multiply, right, because x is being divided, you end up multiplying here 10.2 times 1, which is 10.2, divided by tangent of 15 degrees. So again, here it's all about, notice when it's kind of like given to you in that different information, we're going to end up taking that value and dividing by the ratio, whatever we need to use here. So X here, practicing putting in the calculator, is approximately 38.07 from rounding, or feet. Now we have a unit. So go ahead and pause the video and try the U-try on your own. And here we go. So you're looking for DF. This is our X, which notice is actually opposite from the 90. So we are looking for the hypotenuse. So from our reference angle, what does the 12 represent? Well, notice it's connected. So this is our adjacent. So that's why you had to use cosine for this problem here. Cosine of 15 degrees is equal to adjacent, which is 12, to the hypotenuse, which is X. So again, this is back to that same format, right? Where here you've got X over 12 is the same as 1 over cosine of 15 degrees. So when you multiply both sides by 12, right, you end up taking 12 and divide that by cosine of 15 degrees, which gives you approximately 12.4. And here we're going to do this application problem. So go ahead and read the problem. Now keep in mind, we're talking about direction, which if you need that, right, are north, east, south, and west here. So see how you do with reading through, set this up. Let's see how you do first on your own, at least with the setup. And here we go. So here a boat set sail 27 degrees northeast. So northeast is at a diagonal right between north and east. So here we have a boat. So we're thinking about the water, right? So here's our water. The boat here traveled 27 degrees northeast. After traveling 120 miles, right? So the boat is going at 27 degrees. After traveling 120 miles, realized that they were supposed to go directly east. So they were supposed to go directly east, right? So this is the direction that they were supposed to go. How many miles will the ship have to travel directly south? So here, that means the boat is here. So how far does it have to go directly south to meet up where it was supposed to be? So this is the setup, which means which trig ratio are you supposed to use in this case? Well, you were supposed to use sine, right? Because if you notice here, you've got the opposite, and you do have the hypotenuse. So you have the hypotenuse because that's opposite, and x represents opposite from the 27. So this is sine of 27 degrees, which is equal to opposite, which is x, to 120. So now notice here, all you have to do is just multiply, right, by 120. So that means here, the approximate amount of miles that the boat needs to travel to south is approximately 54.5 miles, or you could put 54.48 miles.